to solve our eighth problem statement. Today is day 8 of our 75-day LeetCode coding challenge. So yeah, let's start. Our problem statement is increasing triplet subsequence. Let's jump start to problem statement. Given an integer array nums, return true if there exists a triple of indices I, j, k such that I should be less than j and j should be less than k and nums I should be less than nums j and num j should be less than nums k. If no such indices exist, return false. Very easier to understand. I should be less than j and j should be less than k. And the value of I, value of that particular index should be less than j and j should be less than k. Basically, triplet in the increasing order. So if we take this example 1, 2, 3, 4, 5, so there are many triplet in this test case. We satisfy this condition, both of these conditions. 1 is less than 2 and obviously 2 is less than 3. 2 is less than 3, 3 is less than 4 also, and 3 is 4, 1, 5, right? And similarly for 5, 4, 3, 2, 1, it is like downgrading. So basically no triplet can exist that can go in the increasing order. So from a start it is going downside, so it is not possible to satisfy the second condition. If we check this array, we have 0, 4, 6 that is going in the increasing order. So the triplet exists. One thing to understand that the ijk value is not like that it will be consecutive only. It can be non-consecutive index also. So if you take this test case 20, 100, 10, 12, 5, 15, so there is no consecutive index that satisfies this condition, right? But there are non-consecutive index that satisfy this condition. Basically 10, 12 is greater than 10 and 13 is greater than 12, right? So this 10, this 12 and this 13, basically I is basically satisfy this condition also and this condition also. So just to remove, just to avoid the confusion, sometimes people when read this problem statement, they think that they are solving only for consecutive indexes. Basically it can be non-consecutive indexes also, and in the whole array any 3 index from start to end should satisfy this condition only, that we should go in the increasing manner. And in between those indexes there can be multiple indexes that are not satisfying those conditions. But if you just plot the graph with these element, you need to pick basically 3 points in the whole graph that is going in the increasing manner, correct? So how can we solve this problem statement? One thing, the condition is I should be less than j, j should be greater than I and k is greater than I. We need to also solve this problem statement into O and time complexity, and also we should not use any extra space. So how can we solve it? First, if we go from left to right, we know that we are going in an increasing index manner. So first condition will always be satisfied, that I will less than k and j less than I. This condition we will satisfy by going from index 0 to length of array, right? This condition is satisfied. Now we need to pick these 3 elements that can satisfy the second condition. What we can do while going from left to right, we can find 2 minimum 1 and minimum 2. So basically we need to find the last 2 minimum while iterating from left to right. And if at any while iterating, if we find any element that is greater than minimum 1 value and also minimum 2 value, then we know that the triplet exists. If these conditions do not satisfy, we know that triplet do not exist. So what we have to do, we need to find 2 minimum. And also remember that minimum 1 should be less than minimum 2. Right? So we need to find the last minimum and the second last minimum. And if during iteration, if we find any element that satisfy these conditions, we know that triplet exists. Otherwise, the triplet do not exist. So yeah, let's try to do the coding part, and we'll try to understand. But you can also run for this test case. Just do the dry run. Like if we do the first index, the last minimum value will be 20, right? Let's call our minimum one A and B. A comma B, right? So A is initialized by 20. Now 100. So now we have A, the least minimum 20 value, but B as a second last minimum. Then we iterate again. Then we get A another minimum 10. And B is still 100. Then we go again 12. So A is equal to 10 and B go to 12. Now we have two minimum 10 and 12. If 5 we ignore it. If we come to 13, then it satisfies this condition. Basically 13 is greater than 10 and 12. So let's write the coding part. So we are defining two minimum A and B. Let initialize with the max value. Now iterate over your array I less than nums dot length I plus plus. We are saying if our nums I is less than A, we are initializing with the A value. So this will be our last minimum value. You can remove the minimum value. Now do the second condition to find the second minimum. What we can do is to find the second minimum, the nums I element, first it should be less than B, and also nums I should be greater than A. Right? So this is the logic to find a second minimum. It should be less than B, but it should be greater than the last minimum value. At this condition, we are saying B equal to nums I. And now let's write our third condition, this one. If at any element we found that nums I is first, if A is less than B and B is less than nums I, if we satisfy the second condition, we can say return true. And if the whole iteration tries, still we are not able to return true, we will return false. The more minimum value, this is the second last minimum value. And now let's run our test case. Our test case is working. Let's submit the solution. Okay, so our solution is also working. Thanks for joining the session. Let's meet tomorrow.